P naught, 2T naught. Okay, this is the graph. Same monoatomic gas, 1 mole. To make things very simple, we have to calculate efficiency, plot equivalent graphs. Find efficiency in one full cycle. And we have to plot equivalent graphs. So there's a temperature, there's a pressure. This will be very important for student like what formula you should prefer. What formula is there? So the same set of formula. Okay, now what is the basic efficiency? Efficiency is net work done by net heat absorbed. No. Okay, no. Net work done. Shall we go for area under PT graph? The answer is no. Only in PV graph, area under the curve is work done. In PT graph, area under curve will not be work done. So what is the method now? Either you calculate work done in each path, calculate the net work done, or else go for Q positive, Q negative. So I think Q positive, Q negative will be preferred one. The Q positive, Q negative is what preferred one. So let's identify what is the 1, 2. Isothermal compression, temperature constant. See this. What is this? Temperature constant. If temperature constant and pressure increasing, so isothermal compression, it will be rejected. There's no other way. Student has to bring his basics. See, temperature constant, so it will be rejected. What about 2, 3? Pressure constant, temperature increasing, so isobaric heating it is, so it will be absorbed. Okay, next again come for this one. 3, 4, temperature constant, pressure decrease, volume increase, so it will be absorbed. Isothermal expansion, so Q3, 4. Now Q41, pressure constant, temperature decrease, so isobaric cooling. If you can, student can think this much, it's so rest all you can manage here. Okay, again ideal gas equation, because to plot equivalent graphs. Okay, here the volume of gas be V naught. So what do you expect volume of gas here? V naught by 2. By seeing only or using ideal gas equation. So this will be again V naught. V naught. Okay, so what about this? So this should be 2 V naught. So now how do you can see? I'll taking help of ideal gas equation. Let it one P naught V1 R T naught, this one. So therefore V1 is equal to what we can write it as T naught by P naught. R T naught by P naught is what V naught. I think everyone is able to think. So finding very difficult. Okay, take a notebook and pen and analyze here. Okay, to plot equivalent graphs, these volumes will help us a lot. Okay, let's go for efficiency. First, we'll calculate efficiency. What do you suggest here? Net work done. Then again, coming Q positive instead what pen? I do prefer to go for Q positive, Q negative. So what is Q positive now? Where all it is absorbed. In which all process it is absorbed, Q23 and Q34. So what is Q23? Isobaric heating, N, number of moles 1. I'll write a formula. Then this will be in isothermal expansion, NR, temperature 2T naught, log of V4 by V3. Okay, number of mole is 1. Monoatomic gas, Cp is how much? 5R by 2. T3, temperature T naught minus T naught, R, 2R, T naught, log of V4 by V3. So 2 V naught by V naught. So directly we are going to get this as phi r by t naught, or this will be 2r t naught log 2. Okay, this is a q positive. Straight away, see, all this within 2 minutes you're supposed to do. So therefore, I suggest you don't write story. Stay, you should able to in exam, no? A student what happened directly should able to write this equation. No need to write this symbol. No, no need to. So q positive. Okay, the in these two processes it is added. Ncp delta T, n equal to 1, Cp phi r by 2. Temperature here 2 T naught, T naught. Then isothermal process nr, temperature of the gas 2 T naught, final volume by initial volume, or initial pressure by final pressure. Anything, since you know pressures, no, you can use take help of that also. I just indicated volume, so I'm expressed in terms of volume. Okay, what about Q negative? Q negative. Q negative will be Q12 plus Q41. Q12 NCP. So this is N temperature log of V naught by 2 by V naught plus N Cp T1 minus T4. Number of moles are T naught log of 1 by 2. So therefore this will be minus log 2. Number of moles 1, phi r by 2. T1 minus this will be. So minus R T naught log 2. Okay, then what is our basic formula for efficiency? Q positive. Okay, now why that mod I'm taking? I think you can justify this. If I don't take the mod here, what is the problem arises? So if I don't take the mod, so what happens? That negative of negative will become positive. Efficiency will become more than 1. Not possible. We don't have any engine whose efficiency will be more than 100%. Not possible. Means you supply 10 joules and you'll get 10 joules and 5 joules heat ejected. So from extra 5 joules from will come, law of energy will get violated. If efficiency of heat engine is more than 100%, law of conservation of energy will get violated. So keeping that in mind, this mod is brought here. Okay, able to understand now? So if I don't take mod, no, negative of negative. Therefore, this mod is adjusted here. Okay, let's see, I think now only mathematics. So this will be phi r T naught 2R T naught log 2. If you want to write it, or let it be R T naught R T naught log 2 all divided by so I think phi R T naught by 2 minus R T naught by 2 will be 3 R T naught. Oh, I think this will cancel, no? These two will cancel out. So this will be R T naught log 2 by 5 by 2 R T naught log 2 5 by 2 2 log 2. Okay, there's a efficiency. It's also very poor. Huh? Not a good machine it is. If you design like this, they'll throw you out of job. Because something efficiency is better, okay, then you'll retain your job. Kidding now? I think it's all about the basic formulas and observation. Nothing else is there. Anybody can understand, anybody can solve. Equivalent graphs, PT graph. What all graphs? PT graph is there. PV graph, VT graph, and Euro graph. The same method, already we have most of the information. Sir, we don't know density. What to do density? Here density, let it be rho naught. What do you expect density? Volume increase, density should increase, no? So 2 rho naught, density rho naught. Here rho naught by 2. Okay, agreed. Overall mass should remain same. Okay, let's go for the equivalent graphs here. So first PT graph I have. Let me go for PV graph. Let me keep this in hand so that plotting will be easy for us. Huh? In yeah. First one, the equivalent graph, PV graph, pressure versus volume. What about the volumes? Volumes will be minimum V naught by 2, maximum 2 V naught, no? And the pressure is P naught, 2 P naught. So P naught, 2 P naught. So rho naught by 2, rho naught. Volumes, V naught by 2, V naught, 2 V naught. Pressure, there's the volume. Okay, let's go for first what should you do? Sir, what is there? This curve will be like this. Then teacher should break students said, that's all. Because you are not thinking. See, that is what actually the human brain, what pen don't wants to think. That there's what like a nobody wants to put pressure on the brain, even myself also. Are you getting this one? It's not that there's a human tendency. We don't want to put effort. Are you getting? So try to analyze yourself. Huh? You don't want to put effort. You don't want to do hard work. There is a human tendency. We have to force ourselves. We have to force ourselves. Okay, let me think. Let me put effort. So what happened? Maximum without effort, we want everything. There's a human tendency. Even for me also, what I want. Without teaching, everyone should get knowledge. And I'm teaching in such a way that okay, everyone will get a rank. Are you getting this one? So there's a human tendency. Please do understand yourself. No, you have to where I'm going wrong, what I'm doing. These are very essential. Students are thinking that something miracle will happen, they'll get knowledge. Not possible. Can I do any miracle where all my students will get a rank? Not possible. Okay, no, similarly, let's identify. What is the one? P naught, V naught, 0.1. What about 2? 2 P naught. Okay, this one. Oh, yeah, yeah, it is. P naught, V naught. This is the one. What about 2? 2 P naught. Here we are here. 2 P naught and V naught by 2. So 2 P naught and V naught by 2. So the point should be here. Okay, no, let's come for point 3. 2 P naught and V naught. 2 P naught and V naught. What about point 4? P naught to V naught. Okay, let's now join the curve. What is this? Okay, straight line I'll bring. Okay, again what we are? We are escaping from thinking. No, before joining the points, look at again, come back and view this one. What is 1, 2? Isothermal process, isothermal compression, isothermal compression in PV graph, rectangular hyperbola. So what is 1, 2? 1, 2 should be a rectangular hyperbola. Okay. I think anybody now? What about 2, 3? Isobaric eating, PV graph, horizontal line. This arrow, some other color. Yeah, no. 3, 4, isothermal expansion. 4, 1, isobaric cooling. Okay, this is equivalent graph. So what I suggest, any question you encounter, plot equivalent graphs. You learn a lot. The thermodynamics will become very easy for you. There's a method of learning thermodynamics. Are you getting no? Any question, they're given PV graph. Okay, plot equivalent graphs, PT graph, all other equivalent graphs. If they're given PT graph, plot other equivalent graphs. If they're given intangible density graph, plot other equivalent graphs. So like that happens, student has to put effort in plotting all equivalent graphs. Then okay, you'll be in better position. Okay, this is about the PV. Okay, we'll go for next the PT graph. Pressure versus okay, PT graph already is, volume versus temperature, will go for it. What about volume? Volume will be V naught by 2 V naught. Volume. Temperature. Temperatures are what, like T naught and 2 T naught. Okay, identify. Now path 1, V naught T naught. So point 1, V naught T naught. Point 2, V naught by 2 and T naught. What about 3? V naught and 2 T naught. What about 4? 2 V naught and 2 T naught. Okay, first we'll identify what is 1, 2. Isothermal compression, vertical line. 2, 3. How you represent isobaric process in PT graph, straight line passing through origin. 3, 4, isothermal. Again, straight line passing through origin. The graph, the curve should be such that straight line passing through origin should come. Okay. You check the book no you have for this graph is asking efficiency. Next, one more problem is there for this graph asking efficiency. Again, is asking for this graph is asking the efficiency. Actually, you think that you are doing 3 problems. Actually, you are doing only 1 problem. So therefore, if you plot equivalent graphs, it understood that as even for this also, you know how to plot the efficiency. Okay, intensity versus density graph. Okay, densities are rho naught by 2, rho naught by 2, rho naught, 3 rho naught by 2, 2 rho naught. Temperature, this is U naught, 2 U naught. This is internal energy. This is about the density. Okay, let's identify the points. First, the point 1. Point 1, what is the density? Rho naught, and temperature T naught means U naught. Rho naught, U naught. Okay, it should be 1. You see, even I too don't know how the curve. First, I'll locate the points. Okay, this is like V naught. Okay, density is rho naught. T naught means U naught. Okay, come for point 2. Density is 2 rho naught and temperature is T naught only, means should be U naught only. So density is 2 rho naught. So therefore the point will come here. Okay, come for this. temperature 2 T naught. So therefore this will be 2 U naught and density will be rho naught. So therefore the point has to be here. So 0.4 rho naught by 2 and 2 U naught. Rho naught by 2 and 2 U naught. Okay, we have points like this. Okay, first we'll come for what is 1, 2? Isothermal process. So isothermal process, how do straight line passing through origin? Also like a horizontal line in Eurograph, Intrinsic constant, isothermal process. Then what about 2, 3? 2, 3 is isobaric process. So rectangular hyperbola. Then it will be like this. Okay, one more. In internal energy versus density graph, you see PT graph. What is this process? Clockwise, no? PV graph, clockwise. There's a volume, no? It is. Yeah. In VT graph, anti-clockwise. At least make observation. In which process? Clockwise cyclic process work done positive, and counterclockwise process the work will be negative. I think in VT graph and Euro graph, anti-clockwise cyclic process work done will be negative. PV graph, PT graph, their open clockwise cyclic process will be positive. Able to notice? I think there's a basic thing what a student must have. If you want, you can go for any other graphs. Huh? You can go for any other graph. Not only this, you can go for any other graphs here. Okay, able to get the idea? This one, how to calculate, how to get the efficiency after getting the efficiency, then how to go for the equivalent graphs here. So one more, we'll take it. Okay, PV got over, PT got over. Now we'll come for VT graph. And then we'll go for paper discussion.